discrete time unit step signal. Okay, but this unit step signal, first one, the unit step, it is notated as u of t. So this is the standard notation of the standard signal. Okay, so unit step means it is mentioned as a u of t. Unit impulse means del of t. Ramp means r of t. Sinusoidal means sin omega t. These are all the standard notation. So here it is a CT means continuous time. Okay, so in this unit step signal, there are two type of unit step signal. One is continuous time unit step. Another one is a discrete time unit step. So first one, the continuous time unit step signal, it is denoted as u of t. Okay, and you see this is the graphical representation of a unit step signal. So what is unit step? So in the name itself, answer is there. Okay, what is step? You know the step. Okay, the step means, you see this graph, before time t equal to 0, the signal is having 0 amplitude. Okay, at time t equal to 0, the signal is the amplitude of that particular signal is raised to 1. Okay, and after that, for time greater than 0, the amplitude remains constant as 1. Okay, so that's why, so the shape of this signal is like a one step. Okay, one step. That's why this signal, it is called as a unit step signal. Okay, so you know, so how to represent mathematically this unit step signal? So the unit step signal is mathematically described as u of t equal to, so what is u of t? How to describe this function? U of t is having the amplitude 1. You see, the u of t signal is having amplitude 1 whenever the time t is greater than or equal to 0. Okay, correct? So for the time t equal to 0 to infinity, the signal is having the amplitude 1. Okay, so for time t less than 0, the signal is having 0 amplitude. So this is the mathematical description of this unit step signal. Okay, and this is a continuous unit step. That's why we have to use the variable small t. Okay, so this is the about continuous time unit step signal. Okay, so for how to describe the unit step signal, you see the unit step signal has amplitude of 1. Okay, 1 means unity for positive values of time t. Okay, that means its value is 1 for t greater than or equal to 0. Okay, for t less than 0, the amplitude is 0. It is said to be the unit step signal. Okay, so the next one, discrete time unit step signal. Okay, so the discrete time unit step signal, it is described as u of n. Okay, u of t means continuous unit step signal. Discrete unit step signal means u of n. Okay, but how to describe the discrete time unit step signal? So you see, you know the discrete time signal. What is discrete time signal? The discrete time signal is having amplitude only at a definite interval of time. Okay, only a particular interval of time. But here for the time n, okay, for discrete we have to use the variable small n. So for the n is from minus infinity to 0, the signal is having 0 amplitude. At n equal to 0, the signal is having amplitude 1. Similarly at n equal to, okay, this is n. Okay, along x-axis we are taking the variable n. Along y-axis amplitude we are taking. So at n equal to 0, 1, 2, 3, 4, 5, etc. At the time instant only, the signal is having the constant amplitude 1. Okay, this is said to be the discrete time unit step signal. Okay, so how to mathematically describe this unit step signal? So u of n is equal to 1 when n is greater than or equal to 0. That is, what is the meaning? N equal to 0, n equal to 1, n equal to 2, n equal to 3, etc. up to infinity, the signal is having amplitude 1. Okay, for n is less than 0, the signal is having amplitude 0. Okay, so this is the mathematical representation of this unit step signal. Okay, so it's an important 2-mark question. Okay, so that's all the unit step signal. And what is the significance of this unit step signal means? So the discrete time unit step signal, it is nothing but, you see, this is the continuous time unit step signal, and this one is a discrete time unit step signal. Okay, so how to derive this discrete unit step signal from continuous unit step signal? The continuous signal is having the constant amplitude 1 in all instant of time, but this discrete signal is having the amplitude 1 but at a discrete instant of time. So how to derive the discrete unit step signal from continuous unit step signal means, so you know, that is in circuit analysis we see. Okay, in circuit analysis, if the unit step, the continuous time unit step signal is given to one circuit, Okay, in that circuit, if you are connecting one switch means, so whenever the switch is closed at a time t equal to 0, so we will get the unit step signal. Okay, so the unit step signal is generated when the DC supply is applied to the circuit. Okay, so for that circuit, you just assume DC supply is applied. Okay, whenever the switch is closed at a time t equal to 0, so the signal coming to that circuit, it is called as the unit step signal. Okay, and the discrete unit step signal, it is nothing but a sampled version of the continuous unit step signal. Okay, so these are all the significance of the unit step signal. And this unit step signal, it plays a very important role in the analysis of system also. Okay, so while studying the system, we will see what is the use of this unit step signal. Okay, so the first standard signal we discussed, and the second standard signal, it is a unit impulse signal. Okay, the other name of unit impulse signal is delta function. Okay, so this is a very important question. Okay, this signal is also a very important signal in the analysis of system. Okay, so that is impulse response. In control system paper itself, always we are deriving the impulse response, and in signals and system also, in the derivation of, that is in the analysis of system, always we derived the what is the impulse response of the system. That is a question. Okay, so this impulse signal, it's a very important thing. Okay, and you see, so in unit impulse signal itself, there are two type of signal. One is continuous time unit step, another one is discrete time unit step. So the notation of unit impulse signal is del of t. Okay, this is the notation. Each standard signal is having their own notation. So the impulse signal, it can be notated as del of t. Okay, del of t. So what is the nature of this impulse signal means? You see, this is the graphical representation of del of t. So you see the graph. So from the graph, what is del of t? So the del of t signal is having value only at a time t equal to 0. At a time t equal to 0, so here we are putting one arrow. So what is the meaning of this arrow means?